Why would someone run one of these blocks? Whoever can guess the weight of the block will get a swag pack. So how much pressure the cast iron, can take before it literally just explodes. Right now we have the 6-liter based KC Turbos engine and then a 6.4-liter block. Both of these actually come from Warren Diesel, and so this one's here for a couple of just to freshen up and to look at the cylinders, look at the bearings, make sure everything's healthy before they really start to lean on this thing. Making a couple small tweaks to the fire ring and a couple other things we'll show you in a minute. And so while this is here, we kind of just wanted to get everything here and talk about what it takes to actually run, a billet block, and why one would ever even consider running a billet block. Obviously no water, so you can't drive them on the street. There is just for competition where the factory blocks eventually at a certain horsepower level, they just explode. We can band-aid them with sleeves and we can fill them, and that all helps, except at a certain point you're just at literally a limit of the cast iron and how much force, how much pressure the cast iron can take before it literally just explodes. So we start off with a bare block. So we get them basically like this from Warren Diesel. Very nice piece. We'll put them on here and get them all prepped up before they're ready to go through machining. So this block here you can see is just a big chunk of aluminum. Warren has got the lifter bushings in it, but we'll go through and we'll line bore the cam and crank tunnels. We've actually just finished the cam tunnel on this one, so we're getting ready to set up and line bore the mains next. Once all that's centered, that's kind of the center geometry of everything for the engine, is where basically your cam and crank tunnel are, kind of determines the kind of the main housing. Those are the points for which everything else is based off of. When we start with a bare chunk like this, really important, because we'll go through and put the cam tunnel in it and then put the mains in it. So if we start there and get all that dialed in really good, then we know everything else, we can base off of good data. And so here, then we'll take these and machine it for sleeves. We use a big top flange sleeve on these, and Warren actually sends us these blocks extra tall. And so on Charlie's block for KC Turbos, we actually cut it back down to about the normal height, but we left the sleeves sticking up 50 thousandths. We might do that on the Rudy's block here too. It'll be another 7-liter. So we like that 4-inch 055 piston size. It actually still gives plenty of meat in between the cylinders. It actually gives it more meat than even some of the Billet Cummins guys have. At a 4055 bore, we don't have to worry about water jackets. We actually still have more meat in between the cylinders than some of the 6.8-liter Cummins. We'll go through, we'll bore the lifters, we'll bore the cylinders, we'll press our sleeves in it. We just use like a power bore sleeve. They've been really good to work with, and so it's a ductile sleeve that we'll press in here, and so these are a really good piece. We'll go through. It takes a lot of work, a lot of spindle time, and both for Warren Diesel to get them to this point to send to us, dozens of hours of machine time. Like I said, we'll take them. We have to put the cam tunnel in. This one we actually just finished putting the cam tunnel in. This one intentionally they make this undersize here, and so you can see this has a pretty hefty step there. So you couldn't put bearings in this and run it. It's just a bare or a partially finished block. We go through and do the finished line boring. So you can see it has this step here, and that's intentional. Warren leaves this undersized when we get them, and then we come back and machine them to the final size. Same with the cam tunnel. The cam tunnel we get unfinished, and then we put the cam tunnel in, and then we'll go through and finish the the lifters, lifter bores, and we've got a little bit of deburring to do. We'll press the the sleeves in. We've got a pretty good system for that now. We heat the blocks up actually in an oven, and then the sleeves drop right in. This one will be going in the Rudy's race program, Rudy's Diesel. If you don't follow them. They have the world's fastest Powerstroke and one of the fastest 4-wheel drives on the planet. And we're hoping to do some big things this year now that we have a power plant we can really lean on. So they've been at the limit of the factory block for years now, and just through creative tuning and really good maintenance and upkeep, and just really being at the very tippy top of their game, Rudy's has managed to make the factory block survive as long as they have. So we're really interested to see what they can do, and they can really lean on it and pour the coals to it with a block that won't split apart. Why would someone run one of these blocks? At a certain power level, north of 1500, we start to see some cracks in the factory cast iron blocks. They'll crack along here. is not uncommon. They'll crack in this region here. And even if we sleeve the factory block, sometimes they'll still crack from sleeve to sleeve in this region here. And so, you know, at a certain point, at a certain power level, somewhere north of 2000, they just explode and they blow chunks of the block off, and it just splits and rips the block into like 2 and 3 big chunks. And so really at the end of the day, it kind of just becomes as much about safety as just, yeah, we want to make more power. You know, you just can't risk, you know, exploding the factory block and dumping 20 quarts of oil all over the track. And, you know, this goes really south really quick at 150 miles an hour or faster. And so, you know, these guys are in the fours. They're looking to stretch deeper into the fours. And I think this is going to be a really good platform to get them there. So we're going to keep the same stroke on the crankshaft, which is 4-inch 134. And then we'll do a 4-inch 055 piston in these. On the KC Turbos block, they've got a little bit of runtime on it now. So, you know, good to get it back here, freshen everything up, look at it. Just make sure before we really start leaning on it really hard to make sure that, you know, everything looks good. We don't have a bearing issue. We don't have any, you know, cylinder issues. And so Jesse Warren's been running his billet block for a couple years now. Drag racing and sled pulling worlds obviously are radically different. You know, drag racing is very crispy clean, all the nitrous, very little smoke. Sled pulling, lots of smoke, and just lots of load, a way longer 20 or 30 second sled pull versus a 5-second drag racing pass. And so just the loads and everything that Jesse might find in clearances and setup on a sled pulling application might differ slightly from what might work from the recipe that works for a drag racing application, just because the use and application is totally different. You know, one is all boost, all fuel, and the other one is lots of nitrous, and lots of nitrous, you know, much shorter pass. Interestingly enough, some of the things and challenges that I don't think of, we're on the East Coast here in North Carolina, on the Outer Banks area of North Carolina. Well, dealing with our buddies at KC Turbos, they're out in Phoenix, Arizona, where it's routinely 110, 120 degrees. So normally with a lot of our race customers, we'll reach out and we'll want to make sure that they're operating these engines. You know, you don't fire up a cold engine and go blow down the track. You know, you fire it up and get some runtime in it. And, and I'll tell customers, and like KC, I said, we'll make sure that we get about 100, 110, 120 degrees in it before the full. And I said, great, no problem. You know, it's 110 degrees here, just ambient temperature, you know, that's like the low for today. So one of the other cool things we did on this block here, you can see it's got a kind of a different head stud in it. And so the factory 6-liter head studs are on the coarse side, they're 14x2, 14 millimeter, which is real close to 9/16. They did 9/16 on the fine thread end. Out of an abundance of caution on the KC block, we actually took that all the way to a 5/8 head stud, and you can see here the difference. Pretty sizable difference between the two studs. Have way more thread engagement. We put these studs deeper into the block, and then on the top side, we actually had to turn down the nut and washer, and all is so big that we actually had to first we had to drill the cylinder heads, which I'll show you in a minute. And then we also had to even turn down the nuts and washers to clear all the rocker assembly with our Gesso rockers. On the KC Turbos billet block, which we've got here for a freshen up. So this has a little bit of runtime on it. We've been doing a lot of testing. We're changing a couple little things in the firing setup, and just kind of looking everything over, because this is the Warren Diesel billet block. So a beautiful piece from Warren Diesel. One of the tweaks we wanted to make, we're doing a fire ring instead of our normal O-ring deal. And, the O-rings work great, 1,000 plus horsepower, and KC Turbos even ran them at 1,500 and approaching 2,000 horsepower for years. And now it's time, as we're starting to look, at even higher and higher horsepower levels, it's time to upgrade to a fire ring. And pros and cons of fire rings, they require hot retorques, so why they're not really great for like a daily driver. But in this kind of application, especially with a billet block and then a filled head, which these are our cast iron heads, we'll be doing actually a billet head for these. That we'll be releasing here very soon, that we partnered with the guys over, Jeremy Wagler and the guys over at Wagler on bringing a billet head to market for these guys. And so anyway, testing a few things out. What we've done here is we've got 120 thousandths fire ring that we've done a few changes here in the fire ring groove. And you can see these rings have actually, we just untorqued everything. This was all torqued together. We just torqued everything, and the rings you can see are actually pressed into the head. We'll have to actually weld these rings out of the head now, because they pressed into the head so tightly. And same with the block side. They're very, very, very tight press fit into the block. So it's kind of like a valve seat around the whole cylinder. And so we're really excited, and it's totally captured too. So if you look at the way we did this, the sleeves actually stick up from the block about 50 thousandths of an inch. And what that allows us to do is tailor some of the crush on the O-ring by changing the thickness of the gasket. We've run copper gaskets in the past. We're actually switching to a graphite style gasket on these. Some are like a factory 7.3 gasket or small block Chevrolet gasket, or every gasket before MLS gaskets were created. And so in this case, the head gasket doesn't even really do the sealing on these, the combustion sealing. It'll just be sealing really our oil drain backs here. But the advantage is that gasket is kind of a consumable and can be changed, and we can order them in different thicknesses, and allows us to kind of tune things, fine tune things in a little bit better. And so anyway, the other change that we made, instead of normally a 14 millimeter stud, which is real close to 9/16, we actually upgraded these to a 5/8 top fuel stud. From our friends over at P1, badass studs here. And so these, in order to run those larger diameter studs, we had to, this is actually a 20 millimeter head, but on an 18 millimeter head, we'd have to drill the head bolt holes larger. We did have to set up and machine the bushings here in the rocker box. You know, these are a steel insert that goes into the rocker box. And so we had to machine the opening here of these to fit the larger head studs. And then we even had to take the Jessel rocker pedestal here and machine where the head studs go through the rocker pedestal larger too, to accept the to accept the 5/8 head studs. And you can see it's a real tight slip fit, but that way everything goes together really tight, really nice, and clamps everything down really securely. So we're really happy with the way this worked out. And actually, if you look at the firing, this is our test ring that we removed, and I had to chisel it out here, so you ignore that little boo-boo there. But if you look at that ring, if I can get it to focus here under the light just right, onto that ring, you can see it has this shiny, right where my finger is here, this shiny right on the edge, inside and outside edge, where you can really tell that it's bit down onto the ring and basically swedged the ring out on either side, where it's basically starting to crush and push that ring out on either side of the gasket. I'm sorry, on either side of the groove here. And what that's going to do is form a really, really tight seal where the ring then is totally captured. So we did a 56,000 deep groove in the block side and a 56,000 deep groove in the head side. And basically that will totally capture and totally crush that ring. And so it cannot blow that ring out. And so if you look here, you know, we have that little sliver of shiny right around here on the inside of the ring. And that should be, I think, a very, very effective head gasket seal. But right now, these are both, our standard bore for these is 4-inch 055. So we still keep the stock 4-inch 134 stroke crankshaft, which puts us right at 428 and some cubic inches, 428 and some change. We'll round up and call it 429, just like Ford did back in the 60s. And so this is what we call our Boss 429 package. So the Billet aluminum blocks are, they are lighter than a factory block, especially they're lighter than a factory filled block. So when you take a factory block and you fill it with, call it concrete or block fill, we actually use MDEPCO 885 or 855. We'll put a link in the comments. It's like a grout that has steel in it, and you fill the block with it. Anyway, by the time you fill the factory block, they end up, even heavier than they already are. If you kind of tilt this guy over, it's crazy how much lighter these things are than the factory cast iron blocks. Whoever can guess the weight of the block will get a swag pack, and then whoever can guess most closely the difference in weight between a factory 6-liter block and the Billet block will announce in another video, and they'll get a free swag pack. Sometimes look really good. Sometimes it's hard to get this stuff to pick up on camera. It's got a little bit of oil and stuff, but they are cross-hatching, still looks pretty good. So in an application like this where there's no water, your oil is doing part of the cooling anyway on every engine in the world. Well, on this engine, your oil is really the only thing doing the cooling. And so having really proper cross-hatching on the cylinder walls helps keep your rings alive. It helps kind of form that gasket seal where the rings glide on the oil up and down in the cylinder walls, which is actually what you want. Well, the only way to really combat high boost and nitrous and stuff is with deeper peaks and valleys in the block. We'll do a separate honing video. We've done a couple different honing videos in the past. We'll do a separate honing video specifically if you guys have questions on that. We get a lot of questions on what should my ring gap be, and how much piston to wall should I run, and my machinist is getting ready to hone the block, and what size should he hone it to? Well, we're gonna answer all those. We've got a separate honing video we're working on. We wanted to go over these blocks and what a cool piece they are. We're really excited to have the 6.4 version here. Super great piece from Jesse and the guys over at Warren Diesel. He's been running his in a sled pulling truck, and if you want to hear what a 7,000 RPM 6-liter Powerstroke sounds like, go follow Jesse Warren and Warren Diesel. And we hope to show you a couple more 6,000-7,000 RPM capable packages here real soon. These things are absolutely going to scream 7 liters, 4-inch 055 bore, which is just a massive, increase over the factory bore size. There still leaves plenty of material in between the cylinders here, and these are going to be a really good piece. We thank all of our race car guys, KC Turbos, Rudy's, Jelly Bill, a lot of the folks that we've had the privilege of working with. We thank them for trusting us to to get them a package and a hold together. We've learned so much working with those guys. It's been amazing. We'll do a build update on these. If you guys want to see, leave in the comments. We can absolutely do a full assembly build just to see what exactly A to Z what goes into a building a 7-liter Powerstroke. Like and share. Thanks for watching. We'll see you next time.